Hey, welcome to Learning with Adam, and today we're going to be learning about standard enthalpies of formation. So, many of you may be wondering what exactly standard enthalpies of formation is. So, actually, in order to answer that, we have to go over what enthalpies is. So, an enthalpy change of a reaction is actually the amount of heat energy that's released or absorbed during a reaction. So using that knowledge, a standard enthalpy of formation of a compound is actually the change in enthalpy that occurs when 1 mole of a compound is formed from its elements, with all substances of their standard in their standard state. So now you may be wondering what exactly is standard state. Alright, so going over standard state. Basically, a standard state is actually the state that substance is in when it's in its most stable form at SATP conditions. And leading on to this, basically if a substance is in a standard state, it has an enthalpy of formation value, which goes by this symbol. So yeah, it has enthalpy of formation value of 0, no matter what. Alright, now although many substances are in their standard state, there are others that aren't. And for those, you can find the enthalpy formation values for those non-standard state substances on page 320 of your chemistry textbook. As you can see, they're all here. They're all the standard enthalpies of formation for several compounds that are not in their standard state. Standard enthalpies of formation are very important because they can be used to calculate the enthalpy change of a reaction using this equation. Alright, now just to explain this equation. So this symbol right here is known as the sum of. So that means is, so if there's basically if you have a product, you have to find the moles of the product, and you have to multiply by the enthalpy formation of that product. And then if you had like another product as well, if you had 2 for example, you'd actually do the same thing for the second product, and then you'd add them both together. Alright, so then after you add those together, you'd have this part done. And then you do the same thing for the reactants. If you had more than one reactant, you do this for the first reactant, and you do the same thing for the second reactant and add them together. Then you subtract the reactants from the products. And then yeah, so this would be the enthalpy change. Enthalpy change. Like I said, this would be the moles of each part and reactant, and this would be the enthalpy of formation. So now we're actually going to use this equation that we learned, and we're actually going to put it into use for one practice question. So right here, here's your practice question. This is asking us to calculate the enthalpy change. So we're just going to use the same equation. So product always comes first. Also, one thing to note here is always check if it's balanced. Right here, we can see that it's balanced. And also, just to let you know, anything that's not a compound will not be added into this equation. So right here, all we have is oxygen gas. It's not a compound, so this will not be part of our equation. So now we'll look at the products. we have 2 moles. Like referring to the equation, we need moles, and then we need standard enthalpy formation. So we have 2 moles of carbon dioxide, and referring to the textbook, the standard enthalpy formation of carbon dioxide is negative 393.5. And then don't forget the symbol we learned, the sum. So now we have to add the other product. So we have 3 moles times the standard enthalpy of formation for water, which is negative 285.8. Right, so now that we have products done, we can move on to reactants. So subtract. There's not anything else to add since it's only one reactant. So you can put it right here. There's only 1 mole. And the standard enthalpy of formation for this is negative 235.2 plus 0, so this has no value. Alright, and now we have to calculate this. So if we calculate it, the answer we should get is negative 1409.2 kilojoules. You can try right now. If this is what you get, then you did it right. And congrats, you solved your first standard enthalpy formation question. Alright, so just to make sure that you guys fully understand this equation and what to do and how to solve standard enthalpies of formation, we're going to do one more question just to see, and if you can understand this, then you should be good. Alright, so in this question, it's asking us to calculate the standard enthalpy formation for ClF3. Alright, so it was different this time, and instead of asking for the enthalpy change, it's actually asking for, it gives us the enthalpy change and it's asking us for the standard enthalpy of formation. So let's use this equation and plug everything in. So looking right here, alright, perfect. So we're going to do negative 1196 equals. So let's look here, is everything balanced? Yep, everything's balanced. Alright, so now that everything's balanced, we can see here what's compound and what isn't. So this is not a compound, N2, so we can cross this one out. This isn't a compound, Cl2, cross that out. This is a compound, this is a compound, this is a compound. So these 3 stay. So now we're going to do products first and the reactants after. So right here we have 6HF. So we know the moles here. So it'll be 6. And I'm looking at the textbook, HF is negative 273.3. Just add the zeros just to keep track. And then we can subtract. You can see here there's 2 moles. But the thing is, we actually don't know what the enthalpy formation is for ClF3. That's what we're trying to solve. So for this one, we're actually just going to put an X as that, and then we're going to do plus. We have 2 moles for this, NH3. And looking to the textbook once again, NH3, the standard enthalpy formation for that is negative 45.9. Alright, so now if we were to solve for all these things, let's go 1196 would equal, so this up here would equal negative 1639.8. Subtract, we're going to put this part. So right here, if we were to put this together and all that, we're going to have negative 91.8, which is right here, this part, plus fix this. Alright, so plus to x. Alright, now all you really gotta do is solve for x. So what's next? Do all the rest, move everything to the other side, things like that. We're gonna get x equal to negative 176 kilojoules. And that is your standard enthalpy formation for CLF3, which is exactly what they're asking you to find, so that's your answer. If you ended up getting this answer after trying by yourself, then congrats, you did this right. And well, that's it for today's lesson on standard enthalpies of formation. Hopefully now you understand how to solve questions by yourself and everything like that. And yeah, thanks for tuning in to Learning with Adam, and tune in next week for another lesson on chemistry. Thanks.